Hey everyone, today we'll be solving a traveling crime scene investigator problem brought to you by Alex Dominguez.
Jarrett Morochek.
And Hannah Maisie.
On August 17th, 2019, there were 14 crimes reported in the 5th Police District of Denver, Colorado. Our goal here is, as a crime scene investigator, you want to visit every crime scene from this day, but your 7-hour workday may prevent you from completing this task. Due to this constraint, you may want to maximize the number of crime scenes you can visit within this time limit. We've also provided a map that shows a distribution of where the crimes took place, as well as what crime they were classified as. We have defined our decision variables as xij being a binary variable determining whether or not a path is taken from crime scene I to j, I being 0 to 14 and j being 0 to 14, with I equals 0 corresponding to the police station and then I equals 14 corresponding to crime scene number 14. The value is 1 if the path is taken and the value is 0 if the path is not taken. We've also included zj, a binary variable determining whether or not a crime scene I is visited, I being 0 to 14 again, and it's a value of 1 if the crime scene is visited, and a value of 0 if the crime scene is not visited.
For our constraints, there are certain crimes that our department prioritizes over others. We must visit all aggravated assault crime scenes. We must visit all auto theft crime scenes. We must visit at least 2 crime scenes involving theft from a vehicle, and any other crime scenes we visit is up to our discretion as long as they fulfill the time constraint and contribute to the maximization of our objective. Our problem also includes constants that correspond to the time we must spend at each crime scene. So we must spend 45 minutes at aggravated assault crime scenes, 45 minutes at auto theft and robbery scenes, 15 minutes at public disorder scenes, 10 minutes at larceny scenes, 30 minutes at scenes that involve theft from motor vehicles, and 30 minutes at all other crimes. Here we have provided our symmetric distance time matrix. Each number in this matrix takes into account the time it takes to travel from crime I to crime J, as well as the time spent at crime I. So the circled number 53 represents the time spent at crime scene 2, as well as the time it takes to travel from crime scene 2 to crime scene 3. Thus, the Cij is C23.
So our problem formulation here is we have to maximize the amount of scenes we go to, so each Zi, subject to our constraints of each Zi and Xij is either a 0 or a 1. The Z0, 1, 2, 6, 11 are crime scenes that we must visit. Those all must be 1. The Z12, 13, and 14, we must visit at least 2 of those. We have our time constraint of 7 hours, and then we have constraints where if we visit a Zi, we must have an Xi, and if we leave an Xj, we must have a Zj. We cannot have any subtours, and then the Xij plus Xji less than equal to 1 eliminates circuits of length 2. Here we have our Xij matrix at the end. From here, you can see we started at the police station, went to crimes 1, 2, and 3, then went to 6, then went to 7, 8, 9, 10, 11, then 13, 14, back to the police station. We skipped crimes 4, 5, and 12. At the end of the day, we visited 12 crime scenes. We spent 7 hours on the road. Now, when we look at the map, it's not going to be a circle because we did not minimize the distance traveled, but instead we maximized the amount of scenes we could visit within our 7-hour time frame.